Hey everybody, welcome to the Acklen Avenue introduces the factory pattern, and I'm joined here with a bunch of friends, colleagues, co-workers from Acklen Avenue and Hero Unit, and we are just here to learn. So I've got a few ideas of some things that I can show you guys, and whoever else is watching this video. Um, and the idea here is for me to try to convey a few things that I've learned through the years, but then also for us to learn a few things together. You guys can maybe teach me a few things. You may have some questions to ask, and if you do, if you think that your question might enrich somebody else's understanding or help you understand it better, then the rule is there is no rule. Just interrupt me. You know, there's no rude. Just go ahead and speak up, and let's not let the moment pass so that we can get all the information out. And also, just because there's a lot of people, uh, if I were to pose a question out there, maybe some of you guys that don't normally speak up during these things, maybe you could stick your neck out and speak up a little bit sometimes, so that we can keep some variety going. And there's a lot of people, but that doesn't mean that only a few people should speak up and have their voices heard. So feel free to unmute your mic when you want to speak up and say something. And if you're not going to say anything, good grief, that was a dramatic noise from this Avengers soundtrack. Anyway, I'm going to keep the Avengers soundtrack going just because sometimes there's silence during these things. But if it's like the moment when they kill somebody, then it might be really dramatic. Who knows? So anyway, let's just dive into the factory pattern. I'll give you my goal for this is to present the pattern as one of the possible tools in your toolbox, and give you some ideas of when it might be useful. What are the smells, or what are the signs that it's the right time to use the factory pattern, and give you some examples of how to use it. We'll do some refactoring on the hospital code that I started last time, and we'll just see how it goes. I'm using C#. Anybody, you could use the exact same pattern with another programming language, Python, JavaScript, whatever you happen to be using. These patterns are they're not limited to one language. Their use is far-reaching. So the factory pattern is often used in conjunction with other patterns, but the main idea behind the factory pattern is that it creates things. So if you wanted to be able to drink from a cup, but you don't have the cup yet, so you could go to a store and buy the materials to make a clay cup. You could also go to another place and buy a machine to spin the clay as you mold it with your hands. You could hire a mentor to teach you how to mold the cup. You could buy the kiln equipment to bake the cup so that it's nice and hard. And then eventually you could fill the cup with water, and that's a lot of trouble. You have to go to a lot of different places. What would probably happen is you're going to go to Walmart and you're going to buy a cup, and so that cup was created by somebody. It could have been created by you, like I said in that illustration. You can do all of the work yourself, or somebody else can create it for you. So typically, what we will do is we will say to a real life factory, "Hey, I need a cup." Or you go to a store and I need a cup, and then they produce a cup for you. Same thing for a car. You wouldn't go and probably wouldn't build a car on your own. You would go to the factory and you would have the factory make you a car. So the factory pattern is very similar, but in the coding world. If the music gets really loud and obnoxious, just let me know. I'm just kind of trying to keep it real. Um, if so, if you go to a factory and ask for a car, then they will ask you some of your criteria, and then they'll just deliver you a car. You don't have to know how to build wheels. You don't have to know how to assemble. You don't have to know how to do any of the work. You just have to know how to drive. So a factory is like that, but in code. Instead, you need some instance of something. You need some construct of something, and so you can go to a factory and you can actually say, "Hey, go and build me this. Here are my criteria. Build me that thing." and then the factory then knows how to create it. So if you're ever feeling like you have no choice but to instantiate something inside of a function, which definitely makes it like completely impure. If you feel like you have no choice, probably the choice that you have is to use a factory pattern. So you saw well, I'll show you some code here. Earlier in my last example with the strategy pattern, I was having to what I call new up a lot of different things right here inside this treat illness method, and we extracted all those different things from a switch into a list of strategies, and then we can do the procedure. So here's an example right here of a place where we could have used the factory pattern. Now we used this can do procedure. And actually, for the benefit of those that didn't see the first class, I'm going to let's see. Let me share this a different way. That way it's a little bit bigger on your screen, and then I can make this text a little bit bigger, I believe. So for the benefit of those that didn't see the strategy pattern video, we basically took a large switch structure that had a lot of different branches for how to treat different illnesses with different criteria, and we extracted all of those out to these different strategies. So this do procedure has these 4 lines that do these different things, and then this strategy or this procedure has these 3 things, and each procedure does things in a little bit different way. And each procedure, each strategy also comes with this method, can do procedure, and this method is what knows whether or not it can do the procedure or not. So in this case, the strategy itself knows about whether or not it's able to handle this strategy or that strategy, or what are the circumstances. So there's some good things and bad things about that, but that's how we did that. We basically took the switch statement, this massive switch statement, and whittled it down into basically 3 lines. That is definitely much cleaner code. There are some things that we could do here in the constructor to make this even cleaner code, which is fodder for another discussion when we talk about dependency injection. But for now, it's good enough. But there is another way that we could do this. There's a better way that we could select which strategy and get it out of here. Basically, we could remove all of this, and we could reduce this down to much cleaner, much just better code in general, and we wouldn't be putting the responsibility of doing this on this hospital class. So that would help us to reduce the number of responsibilities that this class has, and would make this class more maintainable too. So the first thing I was going to do was, in this case, I need to create a strategy, the appropriate strategy, and then I need to do the procedure. So the reason why I say the word create is because that's typically the name of the method that you would have on a factory, is create. So I want to create something, or I want to get an instance of something. So in this case, I want to find the right strategy, and then I want to do the procedure. So I want to extract this code out to another place. So here's how we can do that. I'll go back over to my spec, and I will look at, I'll just go into one of these guys right here, and I'll start up a new spec. Don't be scared by the C# syntax or by this this library that I'm using for testing. It all translates to other languages. So when treating an illness, in this case, I'm leaving the illness very generic. I don't care which one it is, and even in this case, the hospital shouldn't care what the illness actually is either. it should treat the, whoops, it should treat the illness appropriately. I'm on a brand new keyboard, new for me anyway, and so everything I'm doing is much slower. So we're in the hospital, and apparently I've got a namespace that is, yeah, I've got a namespace that's probably named hospital somewhere. So, all right, so I'm going to create the system under test. And then this right here is going to be, I believe it's treat illness, yeah. And then it does not, it does have, yeah, it's got an outcome. So then my input is going to be some medical code, which I shouldn't actually care what that is. And I guess I'll say false here. Yeah, I had to turn the music down. It was killing me. Okay, so this, by the way, if you're ever doing unit tests, should not be null is about the worst way you can observe something. Sometimes it's necessary, almost never though. It's almost always a better way to do that. So the result in this case should, I'm not really sure what it's going to have. Let's see what this has on it. Okay, so it has a list of procedure outcomes. So then let's see, the procedure outcomes should contain equivalent of, and then I'll give it a new procedure outcome of don't know. So I'll just start it there. And I'll move this out to its own class. While I'm typing, would anybody care to put it in your own words what you understand is the reason or when we should use a factory? Anybody?
I think that in simple words is a way just to create the instance, but we can just specify a few things by default if we have a class that create the instance for us.
So you would want to use a factory pattern when you need to create an instance of something.
Yeah, but if that sounds simple, but I think and I will say what's the difference between just a nameline instance and a class that create an instance for me. So what I will say, if I want to have something specific in every instance, or just set a property with a x value, I will use a factory, and also have a constructor or something just to add my custom information or properties.
Right. Yeah, I think that's a good way to say it. Okay, so if I run this test, if I try to run this test, there we go. Yeah, it's loading. Or so I thought. So if I run this test, it will definitely not contain that. It would contain that, or this is actually throwing here because it cannot find a strategy that matches this number, so it's so it can't find first. I believe we're using first here. Yeah, right here. So if it can't find the strategy that matches this, then it will actually throw an exception that it can't find the sequence contains no matching elements. So that's an illness. That is something that we should want to try to avoid. Or we need to throw a more appropriate exception. But for now, I want to, this is already failing because I know that I don't have a strategy. So what I'm going to actually do is, instead of having a, I'm actually going to do some dependency injection, but it's, I'm not going to get into the theory behind it. So I'm going to actually use this right here, and I'm going to call this, this is, I'm setting up a mock or a stub. So I'm going to create a mock of a I procedure strategy factory. So the reason why I'm calling it a strategy factory is because the name of it, to me, it's just better if the name of it describes what it's going to create. So I've got a factory that creates procedure strategies. Okay, so I'll go ahead and move this out to the other project. Not sure which folder yet. I'll just leave it there. And I guess I need to make this public. Yeah. Okay, and so this is already complaining because my constructor for hospital doesn't have this right here. So I'm going to just add it to the constructor. And I'm going to extract this guy out as just, oops, as a field so that I can reuse it. All right, so here's where it is so possible to lose some of you, and so I'm going to try to talk through this a little bit more. When you're unit testing, the context is basically, and this is true for any unit testing framework. If you're in Jasmine or Mocha or something, one of the JavaScript Jest, or you're in one of the JavaScript frameworks, you need to set up the world or the context in which the test is going to run in a separate place from where the assert is actually happening, or the expect. And so here at lines 21 through 24, this is my assert. I'm saying that the result, the procedure outcomes of the result, should contain an equivalent of this object. So then that means that this is going to be the context or the world. Now, what I like about this, and what I like about this more than what I like about Jest, is that this actually separates the action from the context. So this is actually putting the action that we're running on its own line, calls it out. Very easy for developers to see this. So the action is that we're going to treat an illness. So the context is everything that we want to run this test. And so I've got this fake, or this mock I procedure strategy factory that I'm injecting now. I just put into the constructor of the hospital. And now I need to, because it's an interface, it's not even a real object, I need to control it. So it's kind of like a remote control car that I have just sent into this hospital through the constructor. I still hold the remote control right here in my hands. It's right here. Whoops. Something just happened with my screen. Oh, good grief. There's a keyboard shortcut that does that. I don't ever know what that does that, or what it is that does that. So this mock.get is just syntax of the library that I'm using, but it's basically getting the instance of the mock, and I want to set it up. So I want to, x goes to x is just my way of doing this lambda function. So x is the strategy factory, the procedure strategy factory. So I'm going to add a method called create, which is good. It's a good name because it alerts developers that you're using a factory pattern. Aside from the name, it's just a good method name. I'm going to pass in the medical code, And so I need to, and probably whether it's an emergency or not. So since this is a string, I need to extract it as or I should extract it out as a constant so that it can be reused, or else it could become a problem, or I may have to repeat myself, and that gets ugly. So medical code is there, and I will go ahead also and I'll extract this as well. And this is emergency, and I'll say that. So I'm passing in two constants into this method, and I'm going to say that it returns a new. Let's see. Now I need to give it the mock. No. Let's see. I need to give it a strategy. So now I'm going to return another mock. This is the part where I'm sometimes worried about losing somebody, and I'll try to explain it a little bit extra. So I'm going to give it a mock of the strategy that I want to give. So I believe this is called an I procedure strategy. Yeah, there it is. Okay, some of these things are red. I just need to create a few things. So this is a method that I'm going to create on this interface. It's not a void. It's going to be an I procedure strategy. It is a medical code, and it is a Boolean there. So now my interface is good. It's done for this procedure strategy factory. So then everything else is actually not red anymore. This right here is another remote control car that I'm going to pass in. I hope that analogy works for you guys. If you all think of a better analogy, then just please let me know. So I'm actually going to rename a couple of things just to make you to give you a better illustration. RC car 1 parent. And then I'm going to say over here, RC car 2 child. Okay, so I've got this this RC car, the remote control car, the parent that I'm passing into the hospital. I'm going to use that here in just a minute. But for right now, I'm just sending it. It's almost like, anybody ever heard of Stargate? Stargate SG-1 or one of those Stargate shows?
Yeah, I have.
Okay, us old folks have to hang in there for Stargate. It was such a good show.
Yeah, it was.
But basically, it's this portal, this ring portal that's ancient, and apparently you dial in the right codes, and the portal opens, and then you can send like people through, but they would almost always send like a drone through or some sort of like rover, this thing on wheels that would just drive through the portal, and then you would, and if it survived the trip, then they would send people through. This is kind of like your rover that you're sending through the Stargate, or a remote control car if that works better for you. But you can think of this as the ring portal, and I'm sending something in, but I still have access to it. I can still control it because it's a mock. So that's what I'm doing here, is I'm controlling it. I'm saying for this RC car 1 parent, I'm saying whenever somebody on the other side of the portal, whenever somebody calls create and passes in this exact medical code and this exact is emergency, then you should return this other remote control car, which I also have, that I can control and do things with on this side. In fact, I can even let's see, RC car. Let's see. I'll set up another remote control here. Get RC car 2, and now I'm going to set it up a different way. I'm going to say do procedure, and let's see. Yeah, I don't want to do another mock because it's just like sometimes the rabbit hole gets deeper and deeper. So what I can do is I can say mock it is any procedure outcome. Yeah, and that will allow me to That'll allow me to get by this without having to put in a specific thing, though it doesn't like this. Let's see why not. I need to go into this function and see what it wants. Okay, so treatment outcome. Yeah, this is why TDD is so important, because this is actually poorly designed. It's a poorly designed API. It should be returning something. It shouldn't be. Actually, we're gonna refactor this because this is ugly. So the procedure outcome has procedure outcomes. Okay, so there's a treatment outcome and there's a procedure outcome. So we're actually going to rename or refactor this guy. Do procedure should return a procedure outcome. Yep. And we're going to remove that because that's just bad code. You're actually about to see one of my favorite refactoring techniques, which is called break and fix. So I just basically broke this to pieces and nothing's going to build now. So I'm going to have to actually go in and fix all kinds of things. See all this red over here? Yeah, I'm going to have to fix all that. So, so then I don't need this anymore, which is beautiful. So when I do procedure, I'm back to the remote control car, the child. So I'm sending a, this is kind of weird. I'm sending first the first car into the portal, and that first car is able to create another car out of nothing, which I also have control over from inside the spec. So I'm controlling something. I'm controlling something that is, I don't know how to say that. It returns a new procedure outcome, and well, I guess at this point, this is one of my favorite parts about this too, is that when you're dealing with a language that has referential equality, I think JavaScript is the same way, then you can actually test equality by reference, not just by its value. So I'm going to actually pull this out as a field, expected procedure outcome. And then I'm going to replace it with this, with that expected procedure outcome, because this will have referential equality with what I'm expecting over here, which is really nice. Okay, so take a look here. One more time, I've got a remote control car that I'm sending into, that I've got this is the equivalent of a remote control car. I'm sending it into the constructor, sending it through the portal. That remote control car just happens to be a factory, which has a create method. I'm saying, if anybody ever uses this create method with this medical code and this emergency, then it should return this second remote control car, which I also can control. I'm saying whenever anybody calls do procedure on this second remote control car, then it should return this exact expected procedure outcome. The hospital doesn't even have to care what it is or what it returns. All the hospital needs to know is that it did the procedure. Okay, so then I'm passing in medical code here. I'll actually get rid of this guy because it's not necessary. And so then I'm checking the result to see if the procedure outcomes includes this exact expected procedure outcome. So actually, I can remove this now. Should just contain that. Okay, so let's keep this spec in mind. And now I've got to go back and fix all of the things that I broke. We'll see how fast I can do this. So that's not necessary. It's not this, it's a procedure outcome. What is log procedure? Okay, so it doesn't need to return a procedure outcome, it needs to return a a list of procedure outcomes. All right, so I need to go in here and fix this too. So this should be an IEnumerable or an array for you JavaScript people. Okay, so then I need to return a new list of this guy. Yeah, that's great. And then I've got that. You can tell that I've had very little time typing on this keyboard. Well, I don't know, maybe you can't tell. Procedure outcome. Okay, that's much better. All right, so I'm going to copy and paste this because that was just hard to type. Public that. Yeah. Remove those two things. It only needs to do that once. Okay. Anybody ever seen people streaming their video game play on Twitch?
Yep.
Wouldn't this, isn't this just as exciting? Why in the world did that double? General anesthetic, general anesthetic, general anesthetic. And then this one. Okay. Oh, gotta return it. All right, now what's broken? This is broken. So this should be nothing here, and outcome dot procedure outcomes add range is what I would do for this. Or so I thought. Log procedure is what I do. Okay, so I need to go back. So this would be for, yeah, we'll do this. And then we'll say outcome do procedure or log procedure. And I want to pass in the procedure outcome. Okay, so see what else is broken, probably some specs. And so here's a spec that that's broken because I don't have the mock. So I'll do that real quick. Of procedure strategy factory. And I imagine that's going to be something that's very popular. So I'm going to, yeah, do it here. And then here. Oh, it's already there. Break, fix, refactoring. Refactor something, screw it up, and then go in and fix it all. So this do procedure is going to return a new list of procedure outcome, which includes this guy. Yeah. One place left. Okay, so then the result, that's gonna fail. Well, we can figure that out in a few minutes. Okay, so I think we're building now. Now can go back to this one, treating an illness. So just remember, I've got 2 remote control cars or 2 mocks that I'm sending through the portal. This one happens to carry its child with it. So this kind of testing is fun, especially once you get to the point where you can understand that nesting. It's almost like Russian dolls. And this is often, unfortunately, this is kind of common when you're doing factory, especially if you're pairing factory and strategy together. You'll end up with this kind of situation in your testing. But as long as you understand it, as long as you name things well, then it's gonna be fine. So I'm actually gonna rename this. It's not really a remote control car. This is a procedure strategy factory. And this is not really a remote control car. This is actually a procedure strategy. So my factory is going to create a strategy. I happen to have control over the strategy as well. Run this test. It should still fail for the same reasons. Yeah, contains no matching element. So this time I'm going to go into my code, the treat illness, and I'm going to go ahead and make this pass. So instead of saying first can do procedure, and instead of the strategies, I'm actually going to extract this guy. I'm going to rename it first. This is a procedure strategy factory. And then I'll go ahead and create a field for it so that I can access it down here in the method. So what I want is to have a strategy. And I'll use this procedure strategy factory, and I'm just going to simply call create. Then I'll call medical code, and I'll pass in the is emergency. And now I've got my strategy. So then now I can replace all of this with strategy, do procedure. So now the selection of which strategy has been extracted out to the strategy, the procedure strategy factory. So now if I run the test again, it should pass. Let's just see. Yeah. Okay. So this code has been refactored, but how do we then because now we got to implement the factory itself. So we've implemented its use, but now we need to implement the factory itself. How do we do that? How does the factory choose which strategy to deliver? So now that our hospital doesn't have to worry about that, it doesn't have that information, it's not responsible for that information, we can just transfer that information to the factory itself. So I'll create a new spec. And when creating a procedure strategy from medical code, it should return the I wonder which one I should choose. This would be maybe, we can do the tooth pull. It should return the tooth pull strategy. Okay. You know, I should have made a instead of a hospital, I should have done a government overthrow scenario. That would have been more fun to do the factory pattern on, like new Fueraho. Okay, so yeah, like new tank here, or you know, voy a hacer lo que tenga que hacer. So so new. What am I? Now that I've made that joke, so this is the now I've got to deal with the actual concrete thing. I can't just deal with the interface anymore. So this is going to be a brand new thing that doesn't exist quite yet. I'm going to say the default, because I could have many of these things, I guess. Default procedure strategy. Good grief, strategy factory. And I'm going to do this little trick. If you're a C sharper, then you should try this sometime. If you've got resharper loaded, then you can actually do this, and it will actually do a few really cool things for you. So when I create this type, it'll automatically apply the interface, and then I can go ahead and just in almost the same action, I can implement the members. So I'll just return the wrong one on purpose at first, and then I'll go ahead and move this out to the kata folder, just to go ahead and get it in its rightful place. And while I'm at it, I'll go ahead and move this out to another class file, just to keep it clear. All right, so I've got my system under test, which is going to be an iProcedure strategy factory, and then I'm going to create. And then I'm going to pass in, I'm not really sure yet, 1, 2, 3, 4, and false. And so now I will instantiate my field here, the procedure strategy. So what I'm interested in now is not so much like what can it do, but I'm interested to see which strategy it returned to me. So the result, I can say should be of type, and then I'll say tooth pull strategy. Yeah. So I'm wanting to pass in 1, 2, 3, 4, and it returned to me the tooth pull strategy. So actually, I'm going to go right over here, and I'm going to copy this string because I forgot which medical code it was. So that's why unit tests are nice, is because they can remind us of all those things. Okay, so if I run this test right now, I may have to click here. Yeah. If I run this test, I'm expecting that it fails. Yeah. So remember that I intentionally sent the wrong one, and so here I'm expecting the tooth pull strategy, but I got the left arm amputation strategy. Sounds like seguro. Sounds like hospital escuela. Let's see. Yeah, this is definitely not the kind of factory that you want in a real medical situation. So we need to do a lot better than this. So here we can do lots of things. Like we could do the switch structure like we had before, a for each, or no, sorry, not for each, an if structure if we want to. Sometimes that's what you end up extracting out. You know, you've got an if, you got a conditional structure somewhere, and you want to basically just remove that entire structure out to someplace else. So you could, the first refactor that you make could be a factory pattern to a factory to extract the conditional, the decision making out to another place. It still ends up happening. You still have the switch or the big if somewhere, but it's just not in that code where it was before. And what we did last time was we refactored the switch into a list of strategies, which was fine. But we could have also just attacked that problem with a factory. The only problem is we would still end up having the switch. So here I'm returning the wrong one. Basically, what I need now is a way to know, is a way to choose the correct strategy. How am I going to do that? Well, what we had before in the hospital was a list of strategies. Probably what we need to do is extract that list, because it's not really being used anymore. So it's not being used at all down here. So let's extract that. In other words, copy and paste and delete it from the hospital, because it's not needed there anymore. And let's actually just put that in our factory. Once again, I'm not going to use too much dependency injection right now, because I don't want to muddy the waters. But if I were doing this in a production system, I would definitely be injecting this list instead of instantiating it right here. But this is good enough for right now. So what I could do to make this pass is I could send in the tooth pull strategy, and then my test would pass. So I actually want to broaden the scope of this test. So now that let's see, I'll just copy this for a second. All right, so I'm going to go back to my test. I'm going to run the test and show that it's passing, and then I'm going to refactor the test so that it fails. So now I want the same exact code to be able to run with this other medical code, and it should return the right leg amputation strategy. Well, okay, I guess actually the way this should work is I should probably create a test for each one. So this one's creating a procedure strategy from tooth. If we had dependency injection, we could actually avoid all of these extra tests, but I'll do this just for right now. So this is specifically a tooth pull, and this is specifically a right arm amputation medical code. All right, and I think, yeah, no, I didn't have it. So this is, I should change that to left arm. Left arm. That, and then this is going to be a left arm amputation strategy, and left arm amputation. Okay, so then if I run both of these tests, that's the tooth pull. So one should pass, one should fail. Yeah. So the left arm amputation is not passing, because if we look back here, we are only returning one. So to make this work for both, we could have a switch, and we could pick the medical code out of the switch and return the correct strategy, or we could go ahead and do what we were doing before, which was to say strategies dot first X goes to X can do procedure, because remember we have that here Medical code is emergency. And we don't want to actually do the procedure because we just, at this point, we just want to select the procedure. Okay, so now both of these are going to pass. There's a problem that with what we're doing. Really, we shouldn't be. This is basically going to make every one of these pass without without enough unit tests. So we basically have this one right here that's going to pass without. I mean, I could remove it and all my tests will still pass. I can also remove this one and all my tests will still pass. So if we were using dependency injection, we could have more coverage over these things and protect from that future failure. And we could prevent the need from more and more of these tests that are very specific. So that so far, that's just a quick demonstration of one way to use factory pattern. Remember I said that a factory pattern is when you're creating an instance of something. And so in this case, we want to create an instance of, or we want to get and use an instance of a strategy. So using strategy pattern together with factory is able to refactor this code so that it is very, very explicit of what it's meant to do. Not a lot of ways for this kind of code to change. Very few responsibilities. We're just getting the strategy pattern and then we're just executing it, doing the procedure. So I know that we're over time, but I wanted to offer anybody the chance to ask any questions, seek some clarification. If you have your own clarifications, then feel free to add those as well.
I was thinking of a question, and how would you proceed if inside of your strategies there's like a little bit more complex scenario, like if you are amputating an arm but there's still like different ways to do it, like there's strategies inside of the strategies? Does that make sense, or is it
Yeah, it does. Actually, was thinking in this tooth pull strategy, doing the procedure, you might, depending on which number of tooth you're pulling, you might need a different type of wrench or a different tool. So yeah, and that's the beauty of having this extracted out as its own strategy. You may need a tool factory because at runtime you may not know which tooth you're pulling, so you need you may need a tool factory, a tooth tool factory. Pass in the number of tooth that you're trying to pull, and you're able to then get that tool. And this strategy then doesn't have to know which tool it is; it just has to use it.
oh, got it, thank you.
Yeah. So yeah, you can the rabbit hole can go as deep as you need it to go. Just you want to make sure that things are still readable for future developers as well. So the sometimes the better, quote unquote, the engineering, the harder it is to understand for future developers. So you have to balance those things. What else?
Yeah, I was wondering how would you like make it better with dependency injection? Like where specifically would you put put,
Yeah,
put it there?
yeah. Sorry. I just to add a few comments to the question. I would like just to check, like Carlos said, in where places will you use dependency? Maybe would you inject the factory or that you create in the strategy, or it will be
Yeah,
instantiated?
yeah, and I might talk about dependency injection in the next session. Just since it's starting to get undeniable, we can't really get around it now. But you can see here in this constructor, I'm injecting this factory into the
Okay.
hospital. So it is now a what I call a dependency of the hospital. You can't create an instance of this hospital without providing it a factory or breaking things by providing it a null, which it's horrible that C# even has nulls in the first place. But you basically, you're forced to give it a factory of some sort.
Okay.
Which is beautiful. So this is one place where I already used a dependency injection. Another place is in this factory. I would actually pass in here an IEnumerable or an array of I procedure strategies. And I would remove this. Oops. No. There we go. So that my strategies are just injected into the factory, and then all I've got to do is ask for which strategy it is, and then pass in the medical codes for this method. So that's another way that I would use strategy pattern here. Sorry, dependency injection.
Thanks.
Got it. Any other questions? And I know some of you guys are dying to try this out in your own code. Remember I said that it doesn't just apply to C#. I'm just using C# because it happens to be the environment that's on my computer at the moment. It could be Python, it could be Ruby, it could be JavaScript. You can do this in the front end, you can do it in the back end. In fact, your frameworks that you're using already use this pattern at length in order to enable unit testing. So if you are newing something up, like if I were to say monkey equals new monkey, and this monkey is something that I'm going to use later on, probably this is a smell. I'm newing up, I'm instantiating something here. That's a sign or a signal that you need to be using something, maybe the factory pattern. So in this case, you would inject the monkey factory here, and then you would possibly create the monkey here, or you might create the monkey where you're actually going to use it, which is probably the preference. So the challenge then is for the next 2 weeks, use factory pattern as much as it makes sense. Look, find places to use it, and if you want to share your use of the factory pattern, then it'll probably be good for everybody. And if someone wants to, a pair of you wants to try implementing or refactoring something using the factory pattern, and it actually improves the code somehow, then I'll give the pair of you $50 as a gift. We can do an Amazon gift card or whatever you want. So $50 each. We'll do that just to sweeten the deal. So if anybody wants to try this and actually make this work in your code, then go for it. Send me a code review and or a pull request, and point out where you used it. Maybe tell me how you used it, and make sure that it's something that improves your code in some way. Then I'll set you up with some Amazon money. Sound good?
Sounds good.
Awesome. Any takers? Anybody gonna try it?
We'll see.
I guess we will. May the best pair win. All right. Thanks, everybody. Have a wonderful afternoon. Bye.